Hi guys, greetings of the day. I Vijay Tavardhan welcome you to my YouTube channel for learning a subject called as Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per with your syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 15 for the subject, which is based on the radial piston pump. A radial piston pump has the pistons arranged radially in a cylinder block or a perpendicular to the axis of the rotations of the cylindrical block, which is already discussed in one of the previous session. Yes, and you can see it in the figure over here. Now, those radial piston pumps are available in two different basic types. They are called as the radial piston pump with stationary cylindrical block and the radial piston pump with rotating cylindrical block. In case of stationary cylindrical block, the radial piston pump, the cylinder block is kept stationary and the reciprocating motion is imparted to the pistons by rotating the cam. The outer cover is connected to the inlet, which you can see in the figure, and the discharge through a check valve is going to happen. Then, in case of a rotating cylinder block, a radial piston pump, the cylinder block is connected to the driving shaft. The outer ring may be either fixed or rotating with the cylinder block. Along with the cylinder, the pistons confined by thrust ring reciprocates into the slots provided in the cylinder block, causing the pumping action. The cylinder block and the outer rings are eccentrically placed. The pistons are thrown out by the centrifugal force and pushed back because of either eccentricity between the rotor ring and the cylinder block. Then coming to the pump performance, the performance of a pump primarily depends on the materials used for the components and the manufacturing precision. That is, the components manufactured should have very close tolerance and that must be maintained during its different operating conditions. Theoretically, an ideal pump is one which has zero tolerance between its mating parts, which is not feasible. Though clearances are allowed, it should be as small as possible while maintaining proper oil films of lubrication between sliding and rubbing surfaces. The different types of pump efficiencies we are going to discuss. What is called as pump efficiencies? Efficiency of a pump speaks on its performance. To determine performance data, tests are going to carried out on the pumps by the pump manufacturers under operating parameters and the conditions. The overall efficiency of the pumps can be computed by comparing hydraulic output of the system to the mechanical input given by the prime mover. The overall efficiency can be divided into two distinct components. Majorly, they are called as the volumetric efficiency denoted by eta volume and the mechanical efficiency denoted by eta mech. Now let us understand what is called as volumetric efficiency. Volumetric efficiency is the ratio of actual discharge to the theoretical discharge and denoted by eta volume, which I have mentioned. Actual discharge will be always less than the theoretical discharge due to the leakage or flow back of the fluid, and mathematically this is going to be volumetric efficiency is equal to actual discharge of the pump to the theoretical discharge, which is represented by Q actual by QTH. And the volumetric efficiencies are going to have a range of 80 to 90% for the gear pumps is concerned, 82 to 92% for the vane pumps is concerned, and the highest efficiency is there for piston pumps is about 90% to 95%. Coming to the another type of efficiency, that is called as mechanical efficiency. It is a ratio of pump output without leakage to the actual power supplied or given to the pump as the input, and mathematically it is expressed as output power of the pump assuming no leakage to the input power to the pump. This is about the efficiencies. Now let us understand the important mathematical relations of different hydraulic pumps is as follows with the different pump factors. Now there are four pump factor we are going to consider like volumetric displacement, theoretical discharge, theoretical torque and the theoretical power. Now you can see for the gear pump it is given by pi by 4 d naught square minus di square into w, whereas for the vane pump the pi by 4 dc minus dr into ew, whereas for piston pump ap into db into n into tan theta. In the same fashion the theoretical discharge remains same vd into n because vd will be the volumetric discharge. As the gear pump, vane pump and piston pump, the volumetric displacement is going to be varied, but however the speed will be remains constant. Hence the theoretical discharge formula is same, but however the vd value will be keep on changing. In the same fashion the theoretical torque, whatever the volumetric displacement we have calculated for the respective pumps, it will be multiplied by the power p, then we are going to get the theoretical torque. Then what is called as theoretical power? How to calculate? We have a formula, that is angular velocity with respect to it, pi 2 pi n into tth divided by 60 is going to be the theoretical power which we are going to get it for the different pumps. Now what are these parameters? Let us understand more clearly. Whereas the capital D naught refers to the outer radius of the gear, W refers to width of tool, dr refers to the diameter of rotor, W refers to width of vane. Like that the various components has been listed over here for the things which is mentioned here, that you can observe. And what are the factors which are going to influence the selection of the pumps? The various pumps are selected taking into consideration the number of factors influencing the functioning of the hydraulic systems and its applications. The major factors influencing the selection of the pump are one by one, that is discharge or the flow rate, which is capital D, the operating speed capital N, operating pressure P, and the performance, reliability, maintenance cost, noise, power loss, necessity of heat exchanger, wear and tear of the pump, desired service life, operating environment and the fuel used, or the fluid used are called as the various factors which affects the selection of the pump. By this I am going to close the session. Thanks for your patience listening to the session, and if you have any sort of doubts feel free to use the comment section for the further discussion. I will answer all your questions related to the topics covered in the session, and don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan. Bye bye.